Okay, let's talk about soil moisture and how to use it to solve a couple of problems. Soil moisture content tells us how much water is available for plants growing in the soil. I'm going to show how to convert between gravimetric moisture content and volumetric moisture content using soil bulk density. I'll then use these values to figure out how much water there is in an area of ground. We could use the same approach if we wanted to convert from nutrient concentration per gram of soil to nutrient content in a volume of soil or in an area of ground. Gravimetric moisture content is the mass of water in the soil divided by the dry mass of soil. To measure the mass of water in soil, subtract the dry mass from the wet mass. Gravimetric moisture content is then simply the mass of water over the soil dry weight. Volumetric moisture content is similar to gravimetric moisture content because we use the mass of water in the soil to calculate both. But for volumetric moisture content, the mass of water is divided by the soil core volume. In other words, volumetric moisture content is the mass of water over the known volume. We get soil bulk density by knowing the volume of soil taken in the field. Bulk density is the soil dry mass divided by the volume. Bulk density lets us convert between weight and volume measurements. Common units for soil bulk density are grams per cubic centimeter. To convert from gravimetric moisture content to volumetric moisture content, multiply gravimetric content by the soil bulk density. This converts from grams per gram to grams per cubic centimeter. Let's use these measurements to answer a typical question. If you know the soil bulk density and the gravimetric moisture content, how many grams of water are stored in 1 hectare of ground to a depth of 120 centimeters? To solve this problem, we use volumetric moisture content because the answer needs to be expressed on a ground area basis. I just showed you that the volumetric moisture content is the bulk density times the gravimetric moisture content. Then the total volume is the volume of soil in 1 hectare to a depth of 120 centimeters. To set this problem up, start by writing the target value on the left. How many grams of water are stored in a hectare? Then write in the known values after the equal sign. We know the bulk density is 1.2 grams per cc. We know the gravimetric moisture content is 1.7 grams of water per gram of soil, which is 17% moisture. And we know the depth is 120 centimeters. A hectare is 10,000 square meters, and that needs to be converted to centimeters. So this whole quantity under the bracket is total soil volume in cubic centimeters. Make sure the units cancel so that they are the same on the left of the equal sign as they are on the right, and multiply the values together to calculate the answer. From these calculations, we find that there are 2.4 times 10 to the 9th grams of water stored in 1 hectare to a depth of 120 centimeters. That's 2.4 billion grams of water. We could also calculate available water on this site to answer another question. If the 17% gravimetric moisture content that I just calculated is field capacity and permanent wilting point is 8%, how much of the total water is available for the plants? To answer this question, we make the same calculation for both field capacity and wilting point, and the difference between them is available water. So, of the 2.4 billion grams of water stored in the soil, 1.3 billion grams is available for plants per hectare to a depth of 1.2 meters, which equals 1.3 million kilos. Since a kilo of water is 1 liter, this soil has 1.3 million liters of available water. That may seem like a lot, but 1 hectare of forest can transpire 20,000 liters per day in summer. So without any summer rainfall, which is a common occurrence in Idaho, that soil, starting at field capacity, might only supply a forest for 2 months, which is the average length of our summer drought. Of course, as the soil dries out, trees will decrease their transpiration rate and conserve the available moisture and might last longer than 2 months if the drought is extended. Here I've shown how to convert between gravimetric and volumetric moisture content, how to use that conversion to calculate the quantity of stored water in a unit of ground, and how to calculate the amount of available water for plants. The same calculation can be used to figure other quantities in the soil, like carbon and nutrients.